to get through it the best I can. But please don't be too loud because that's going to make it really, really hard. Okay. Okay, so today we're going to be doing 5.1, which is operations with polynomials. So the very first question that you have on your notes is, can you guys stop throwing those because you never pick them up, and then I got to pick them up. Okay, so we have a situation where we have a binomial to the fourth power, right? Oh wait, I forgot to do the introduction slide. Sorry. Just jumping right in. So this basically is a slide with a bunch of rules that you need to know about polynomials. This right here is all the rules that we deal with polynomials. We have the product rule, quotient rule, and power rule. These are the ones that we use most frequently right here. Product rule states that if you have the same base, so like x times x, you can add their exponents. You actually do this all the time. X times x is x to the first times x to the first. 1 plus 1 is 2. That's how you get x to the second power. Okay? So you basically add the exponents when the base is the same. Quotient rule is when you're dividing two things with the same base, you're going to subtract the exponents. And then power rule is where you put, if you have something like x to the third, then x to the second on the outside, you multiply those powers. And then we have some other rules. Of course, negative exponent rule. If you have a negative exponent, you want to make it positive, you can bring it up to the numerator. All right. And then zero exponent rule is one people forget about a lot. Anything to the 0 power is 1, with the exception of 0. 0 to the 0 power is undefined. Okay? It's undefined. All right, so everybody ready to go ahead and look at some examples? So the point of the very first example that you're going to look at is going to be this one right here. So the purpose of this example is for you to understand, because a lot of people make this mistake. If they see something like x plus y to the fourth, they go x to the fourth plus y to the fourth. Okay? That's not how you have to do it. You have to do something called expanding it. So you have to multiply each of these out separately. Now we're not going to go ahead and do that today because it's going to take us a long time. You'd have to multiply these together first, then multiply these, and then multiply them all together. It would take a lot of work, but ultimately you're going to get this. So go ahead and write that down. On Monday, you're going to learn about a way to expand polynomials without actually using them. Okay? Make sure you're getting this down. So let me know when you guys are good with that. Okay. So next question we're going to look at is going to be this one. So this one says expand xy to the fourth. So this question's a little bit different than the last one. This one, what is the operation between those two variables? Multiplication. So this one you can just apply the power to each one, okay? So essentially what you have here is x to the first times y to the first, all to the power of 4. So this is what we call the power to power rule. When we apply the power to power rule, we're essentially multiplying those exponents together. So this is going to become x to the fourth times y to the fourth. Okay? So that's what you're going to end up getting when you do that. All right. So now we're going to go ahead and actually deal with some polynomial expressions and other expressions. And we're going to simplify them. So looking at this one, I like to deal with the number part first, and then I'm going to deal with the exponent part. So how many times would 7 go into 14? 2. So that's going to stay up top on the numerator, right? So sometimes your numerator is going to keep the number, sometimes not. If it were 7 over 14, the 2 would go in the denominator, right? And then we're going to deal with division of common bases. So what would be 7, or x to the 7th divided by x to the 4th? X to the 3rd. Y to the 9th divided by y to the 6th? Y to the 3rd. Notice here there's nothing left in the denominator, so we no longer need to write a denominator. So this is going to be our final answer. Okay? Yes?
Well, why are we going like put it on the top?
Oh, why is it on the top and not the bottom?
Yeah.
Because the one with the higher exponent is going to keep it.
Okay, just keep it.
Yeah, the one with the higher exponent keeps it. Numerator versus denominator. Alright. Next one. So this one we're gonna have to simplify first before we deal with the division part. So in the numerator we have 3a to the first, b to the first, if you want to put those on there to help you understand it. And then what would c to the 0 be? 1. So do I need to write that?
No.
No, you can just leave it out because it's just 1. Now as for the denominator, we want to get rid of that negative exponent. What should we do with that? Put it up, good. So if you ever want something that's a negative exponent to become positive, if it's in the denominator, you're going to move it to the numerator. If it's in the numerator, you're going to move it to the denominator. Okay, you're going to move it opposite of where it is. So this is going to become 9b to the second power. Now, as you can see, once again, we're left with no denominator. So now we just need to simplify this as much as possible. So this is just going to become 3ab, or a1, b1 if you want to put that in. What would be 9 to the second power? Good, and b would be b squared. Now we're at the stage where we're just going to multiply everything together. So 3 times 81 is 243, good. There's only one a, so it's just going to stay a. And then b is going to be to the third power. You got to add those exponents with the common bases. So does anybody have any questions about how we got that? Okay. Next one is letter C. So with letter C, we have to apply that power to power rule first. So we're going to put everything to the second power. What is 20 to the second power going to be? 400. And it's going to be x to the negative 2 power. Remember, power to power, you multiply. Okay? The denominator, what is going to be negative 5 to the second power? Good. And then it's going to be x to the 6th. Good. Now to simplify this, does 25 evenly go into 400?
Yes.
How many times? 16. Very good. So this is going to be 16. And then I still have that 6 or x to the 6 in the denominator. What can I do with this one here to make it positive? Bring it down to the denominator. So it's going to be times x to the second. And when you bring anything up or down, it's going to be multiplied by what's already there. Okay? So this is going to ultimately become 16 all over x to the 8th. So be sure not to confuse when you multiply versus when you add. You know you're going to add when you have two of those variables written out. That's when you're going to add. You're going to multiply when you have that variable like a double power on it. Okay? All right. Next one. So this one here, we're just going to start multiplying these. This is going to be 12x to the w to the third, and then just y. So any questions about how I got that? Look it over. Yes. So yeah, I got the 12, right? The x, everything has an implied power of 1 if there's not a power on it. So since we're multiplying like bases, you're going to add the exponent. So x times x is just going to be 1 plus 1. So x to the second. W has a 2 on it, and this w has a 1. So it adds up to 3, and then since there's no other y, it's just the y just comes along because there's only 1. You don't have to FOIL it because FOIL is only necessary for binomials. These are actually both monomials. So a monomial is a single term because we know it's a single term because there's no addition or subtraction separating those terms. So addition and subtraction is what separates terms. Yes?
Variables have to go in alphabetical order?
Not unless specified. But multiple choice often will be in that order. All right, this one here. 2 times negative 7 is? Good. X to the negative third times x to the fifth is going to be x to the second. You add them. If there's two variables present, you know that's when you add them. y is going to be to the negative 3. Now, our rules, we can't leave our answer with any negative exponents. So to make this exponent negative, we're going to have to bring it to, or positive, we need to bring it to the denominator. So in the final answer, unless, maybe it's possible you have a multiple choice question that has it written like that, but oftentimes your multiple choice question is going to write it in a way that makes that exponent positive, okay? All right, so this is where all the power to power comes into play. What is negative 3 to the third power? Negative 27. So that's negative 3 times negative 3 times negative 20, or negative 3, which is negative 27. What is x to the third, then to the third again? X to the 9. That's when you multiply. And then it's going to be y to the 6th. So try to get a grasp of the difference between when you multiply and when you add. All right. Now we're going to talk about combining like terms. Sometimes you're going to have this kind of situation where they're being subtracted. When it's being subtracted, I need to distribute a negative 1. So I'm going to rewrite the first set of parentheses the way it is. And then for the second one, it's actually going to change the sign of everything. So everything's just going to change to the opposite sign. And now I'm at the point where I can now just start combining like terms. So 2a to the third minus a to the third is going to be just regular a to the third. And then we have 5a plus 3a, which is, and then finally we have negative 7 minus 2, which is negative 9. So that's our final answer. So make sure you're familiar with how to do those steps. I know you've seen this all before. This is a review, right? All right.
Do you just like stop doing it there? It's just like
Oh, yeah, good question. So the reason that we have to stop here is because none of these are like terms. So I can't like go about adding or combining any of them because they all have different exponents on them. Okay?
Wait, that's easy. You just switch the signs in the bottom.
Yeah, exactly.
That doesn't make sense. It's easy. No, it's not. No, I'm confused now.
All right, so for this one here, this one is addition. So do I have to worry about distributing a negative? No, so now I'm just identifying like terms. So as you can see, we got like terms. We got like terms. And then we have more like terms. So these are the ones that we're going to be able to combine. So we end up with 2x squared minus 14x, and that's going to be minus 3. So that's where I got those from. And that's going to be our final answer. And you can just leave it just like that. So does anybody have any questions about combining like terms? All right. Now we're going to talk about how we can multiply polynomial expressions. So somebody asked about FOIL. FOIL is when we have two binomials that we're multiplying together. But are these both binomials? No, one's a binomial, one's a trinomial. And they're both each fully simplified. So there's two ways to go about doing this. You can either go ahead and use the arrows. There's going to be 6 things you're multiplying. But the way I actually like to do it is with this box method.
Oh, I love the box method. I understand that.
I'm glad you do. So, with the box method, here's how you know how many boxes to set up. There's 3 terms here, right? And this one has 2 terms. So the box has to be 3 by 2 or 2 by 3, okay? So I'm going to write them on the sides, a plus 2. And then the other side is going to be a squared plus 3a minus 4. And then we're just going to multiply the corners. So what's a times a squared? A cubed. What's 2 times a squared? Good. A times 3a? 3a squared. 3a times 2? Good. A times negative 4? Good. And lastly? Negative 8. Now you're going to notice when you use this method, more often than not, you're going to end up with some like terms in the boxes. So when you go to write it out as a sentence, you can just go ahead and combine those. So it's going to be a cubed plus 5a squared plus 2a minus 8. Yes, good question. So on the next one, I'll actually do FOIL so you can see it both ways. So does anybody have any questions about how to use the box method?
No.
Okay. So this other one, say you didn't want to use the box method, here's the other way you could go about doing it. So you can do a similar idea to FOIL, it's just the distributive property. It's not going to be exactly FOIL because there's actually 6 things you're multiplying by. So I'm going to show you the way you can do it using FOIL. But if you see this way and you're like, I really don't like it, I like to use the box, use whatever's going to get you the right results, okay? So for this one, we're going to go ahead and we're going to multiply 3x out to everything here first. So I'm going to multiply 3x by everything. So this is going to be 6x cubed minus 12x squared plus 15x. So I just multiplied each of these terms by that 3x. And now I'm going to do the same thing with the negative 1. I'm going to multiply it out to each one. So that's now going to be minus 2x squared plus 4x minus 5. And then from here, you're just going to identify and combine like terms.
I got
6x cubed minus 14x squared plus 19x.
Wait, how'd you get plus 19?
got a problem right.
Oh.
Do you find it?
Mm-hmm.
Okay.
What'd you say?
I thought it was 4.
All right. Does anyone have any questions about this?
No, I don't have any questions. I understand it and I got it right before you did.
Good. I'm so happy for you. I wasn't just asking you.
Oh, I was answering.
No, I mean, I'm glad. Okay. We got 2 more things to do before you guys go off on your own and do some homework.
Wow.
So you're also going to see something like this, where I'm going to give you some functions, and you're going to have to use them to do different operations on functions. So the very first one says f of x plus g of x. So you're going to have to add these together. So we're going to take our f of x function, and we're going to add it to our g of x function. Now this is really important. If you were going to have to subtract one from the other, what do you have to make sure you do when you do subtraction? You have to make sure you distribute that negative. But in this case, we don't have to do that, right? So just be careful. There are some on the homework where you have to distribute the negative 1. So I just want to make sure I put it out there for you. When I combine these like terms, this is just going to give me 6x squared plus 2x plus 2. Very good. All right, for the next one, you're going to have to take the f of x function, and you're going to multiply it by 2. And then you're going to take the g of x function, and you're going to multiply it by 3. So what property are we going to use to be able to simplify this? Distributive property. So you're going to use the distributive property on both. That's going to give you 4x squared plus 6x plus 4 plus 12x squared minus 3x. And then you're just going to identify and combine all the like terms. And you should end up with something like this. All right, so we're going to pass out your homework. You have the rest of the period to work on it, which is about 25 minutes.